All right, today we're going to be talking about flow control, and we're going to talk how code executes in your computer, and then we're going to look in particular at looping structures and at conditional branching. Excellent. So let's start with looping. So a loop is a set of instructions that is executed over and over again until a condition is met. This condition may be a certain number of times loop is executed, or it's fulfilled some kind of condition. And the condition is a statement that would return what we call a Boolean value, meaning true or false. And an example of this is you go to the shopping mall, and let's say you're driving there. And what you do is that you drive up and down the rows until you find a open parking spot. And once you've found that open parking spot, you stop searching and you just park. So we're looking for the condition found parking spot. Usually that's false, so you keep going, and when you find it, it's true, and that loop finishes executing. So another example is that this is something indicative of doing something a set number of times, is that let's say you are baking cookies. When you finish baking cookies, you pull the cookie sheet out of the oven, and there are 24 cookies on the sheet. One by one, after it's cooled a little bit, you remove each of the cookies from the sheet and put them on a rack. So that's something where you do 24 times. You're not going to stop at 18 times because you got 6 cookies left. And after you've pulled all the cookies off, after the 24 cookies off, you can't pull more cookies off. There's no more. So now let's look at 3 of the more popular loops that Ruby offers. The first is the while loop, and it looks something like this. While condition code goes here, end. And what happens here is that whatever code goes in here gets executed so long as this condition is true. So maybe if we were to pseudocode, kind of write some fake code, and we could do something like while parking spot dot full, while parking spot is full, keep looking. Right? So this is one of the things that's great about Ruby, is that this is very English-like. So we are doing this as long as parking spot dot full returns a true value for us. So that is the while loop. We also have the until loop. If I can type. And this will execute if it's false, and it will stop when it turns to true. It's kind of the opposite of while. So for this, we would change it to until the parking spot is empty, keep driving, right? You're going to keep, if the parking spot is not empty, you keep driving. The parking spot's not empty, you keep driving. Or the parking spot's full, you keep driving. But when you find an empty parking spot, you finish, you stop driving, you park the car. Awesome. So those are the 2 kind of opposite loops. And now we have the times loop. Now this one's a little different. Let's go back to the cookies example, right? We want to do something 24 times. So we would do this. 24.times do pull cookie? Yeah, like you're pulling a cookie off the cookie sheet. I don't know a better way to describe that, but you want whatever this is to be done 24 times. And what this will do, we pull cookie. If I wanted to, let's do this. 5 times do puts hello there. this, when I run Ruby flow control down here, it's going to print out to the screen hello there 5 times. This is awesome. So on top of that, we also have a different kind of loop that we can add to this that'll actually let us track what number we're on. So let's do this. 5 times do number puts, this is time number. And what this should do is that as we print out this out 5 times, it'll count for us and let us know which iteration we're on. And when we run it, as we can see, it prints out 5 times starting at 0. So we can track where we are in these loops, which is fantastic. Now, if loops are dangerous, because we can get stuck. We've both seen with the while loop and the until loop that they will run this whatever's inside the loop until it meets a condition. So here's the question: what happens if it never meets that condition? Well, when that happens, what it does is that it gets into the state called being an infinite loop, and we're going to show you that right now. We're set count equal to 0, loop do count plus equals 1, break if count is 3, end. So when we run here, it's going to run this thing 3 times. Just let me throw this in here. There. Oh. And this is another kind of loop. And we use the break statement to kind of forcibly exit the loop. So what we're doing is saying count, we're going to start at 0, we're going to add 1 to it. And when this count value hits 3, we are going to stop. So 0, okay, we're at it, count equals 1, it prints out, here we go. Count is not equals to 3, remember we evaluate right to left. Count is not equal to 3, we're going to go back here. So count plus equals 1, so now count is 2, prints out, here we go. Does count equal 3? No, it doesn't, goes back around. So I'm going to pause here, pause the video here, and tell me how many times you're going to see here we go printed to the screen. I'm going to run it now because presumably you've made your guess, and 3 times, right? Because it checks here. So what happens if we do this? We're taking this condition out. When will this ever stop? Well, let's do puts, here we go. If I can type today, I'm going to run it. And here's a problem. We have no kind of break condition here. So it's going to keep counting until whenever. And how do we get out of problems like this? Well, what we do is Control C. When we do Control C, it kind of forces a break in the program. All right, so let's talk about branching. In programming, branching refers to a choice that is made depending on whether or not a condition is true or false. You want to think of it as kind of like choose your own adventure. In the example here, we're going to use is if a student earns a 3.8 GPA or higher, they're invited to the honor roll ceremony. And that looks like something like this. So what, in general, our if statement will look like this. If condition code to execute end. Right? We have if and then condition code to execute. So let's translate this into our single branch condition that we have earlier. So if student GPA is greater than 3.8, invite to honor roll ceremony. Right? We can actually do this and do something like puts you're invited. And over here, student GPA. Let's make our first student just missing it. We run the code and we see that nothing happens. But let's change this to 4.0. And we see that the student is indeed invited. Fantastic. So that's a simple one branch system. So this is great, but believe it or not, the real world may be a little more complicated. So let's look at a two branch situation. Let's say if I have more than $100, I'm going to eat at a fancy restaurant. And if not, I'm going to cook at home. Let's see, call cash. We'll just put $20 for now. And so we're going to do it. We're going to use this syntax. If cash is greater than $100, and we're going to write the code that's going to execute. Do puts. Go into fancy pants place. And now we want to have the other condition. Else puts Kraft mac and cheese. I am not denigrating Kraft mac and cheese. I'm just saying that it is not a fancy pants place. And we close it with end. So now we're going to run, oops. And we see that cash being $20, we're having mac and cheese. Oh, I'm sorry. We have lots of money. We are going to a fancy pants place. Cool. So now we have two branches. But what about more? What if under $5 you're going to have ramen? Right. So let's kind of alter this. We're going to introduce the else if. Oops. Right. So the way I want to structure this is go from low to high. If cash is less than 5, puts having some ramen. Else if cash is less than 100, puts having mac and cheese. Else puts fancy pants. So you notice here that I have an else if, and it checks the thing, and else does not take an argument. So it's pretty much saying that, well, if we're not less than 5 and we're not less than 100, then it has to be over 100, and that's going to be fancy pants. So when I run this here, it should be fancy pants. If I change this to 50, oops. This should be mac and cheese. And $3 is having some ramen. And I want to draw your attention to the fact of the order. I put these in ascending order because what if we did something like this? When we do something like this, well, if I have $50, if I have $3, it's going to say having some ramen because 3 is less than 100 and it's going to go here and it's going to quit. However, it'll never hit this branch whatsoever. So be careful about how you order your conditionals. It's really important and really easy to kind of mess that up. So today we've talked about a whole bunch of flow control. We talked about loops. And one thing you can do is that for exercise, like you will try making a guessing game. Where you have a secret number and they're trying to guess. You'd combine the loops and the conditionals. Have yourself guess a number from 1 to 10. This has been Flow Control. Have a good one.